Let's understand accuracy and precision in measurements in this video. Have you ever weighed sugar and got different results each time? Or missed the true weight by a lot? Such moments show why accuracy and precision matter in experiments and in daily life. Accuracy means how close a measured value is to the true value. For example, if a scale shows 3.2 kilograms but the true mass is 10 kilograms, that result is not accurate. Precision means how close repeated measurements are to each other. If you weigh the same object 5 times and get 3.2 each time, those measurements are very precise. Precision and accuracy are independent. A set of values can be precise but not accurate, or accurate but not precise. Let us see two types of precision: repeatability and reproducibility. Repeatability means you get similar results when you measure again under the same conditions and in a short time. Reproducibility means different people, tools, or times still give similar results using the same method. A simple way to imagine this is a football player aiming for the goal. If the player scores, he is accurate. If he hits the same post every time, he is precise but not accurate. A player who hits the same target and scores is both precise and accurate. Now, what is an error in measurement? Error is the difference between the measured value and the true value. Errors come in three main groups: systematic errors, random errors, and gross errors. Systematic errors have identifiable causes and can be reduced when we know the cause. Instrumental errors come from the instrument, like a poor design or a faulty scale. Environmental errors come from conditions like temperature, pressure, humidity, dust, or vibrations. Observational errors happen due to wrong setup or carelessness while taking the reading. Random errors happen for unknown reasons and change in size and sign each time. We can reduce random errors by repeating the measurement many times and taking the average. In fact, the random error in the average decreases roughly as 1 divided by the square root of the number of observations. Gross errors are simple human mistakes, like reading the wrong mark, recording wrong numbers, or using the wrong value in a calculation. Training and careful work help to avoid gross errors. Now, how do we show errors in numbers? Absolute error is the difference between the true value and the measured value. If measurements are 1 or 2 up to a n are taken, the mean AM equals the sum of a 1 plus a 2 and so on divided by n. The absolute error for a reading is a m minus that reading, and we often report a measurement as measured value plus or minus delta A. Relative or fractional error is the mean absolute error divided by the true value or the mean value, and percentage error is this times 100. For example, an error of 2 centimeters on 100 centimeters is 2% error. Propagation rules tell us how errors combine in calculations. For addition or subtraction, the maximum absolute error in the result equals the sum of absolute errors of each quantity. For multiplication or division, the fractional error in the result equals the sum of fractional errors of the factors. If a quantity is raised to a power, the fractional error in the result equals that power times the fractional error of the quantity. The least count is the smallest measurement an instrument can read, and smaller least count means better accuracy. For vernier calipers, the least count equals 1 main scale division minus 1 vernier scale division. And for a screw gauge, least count equals pitch divided by the number of divisions on the circular scale. So, what do we learn from this? We learn the difference between accuracy and precision, the main types of errors, how to represent errors, how errors add up in math, and the meaning of least count. Let us quickly remember. Accuracy is closeness to true value. Precision is repeatability. Systematic errors are controllable. Random errors reduce with repeats. And least count limits precision. Keep practicing careful measurement and check your instruments and method each time you measure. Thank you for listening. Keep exploring and learning more on EduRev in a calm and curious way.